But first, let's do our first experiment. Okay. So what we'll do is we'll take out two fingers. Okay. And we'll touch with one finger we'll touch our nose, and with the other finger we'll touch our toe or a toenail. Okay. So like touch touch them together, and then maybe type in there if you can feel that those both those touches together, or do you feel both of these touches separate in time? So let me give you 30 seconds to touch and type in your response. Okay, so Hina feels first the nose. Okay, separate. So Swarna feels the toe before nose. Interesting. Okay, separate in time. That's Ria. Separate in time. That's Sonali. I feel each. Okay, based on the focus, separate. So you can just write separate or same, right? That'll be easier for me. First toe, later nose, nose. Okay, separate nose then toe. Yeah, so it's a mixed response. Huh? Interesting. Now, if you if you look at it, what's really happening? Okay, what's really happening? Um, so when you touch your nose, uh, nose is closer to brain. Okay. Um, well, um, okay. Let me. So the reason why there are two of these mixed responses is, so first of all, your arm length is same. Okay. So whether you touch your toe or you touch your nose, if you're feeling this finger, okay, um, this finger is equidistance from your brain, and therefore in your head, in your brain, if you're feeling this finger, um, it'll be the similar response time. Okay, but some people might be feeling the touch of the nose, not the finger, right? And your nose is closer to your brain, which means the signal from the nose will travel faster to the brain, and your toe is, well, it's farther from the brain, of course, right? So the signal will take more time, and therefore some people might experience um, nose feeling, faster in time than the toe. So yeah. Anyways, so the point I'm trying to make is, so brain works on these objective, you know, rules. So we think brain is this subjective nonsense in our head, and it decides whatever it decides. But really, it is about these electrical impulses moving from your body, and yada yada yada. Right. So we will talk about these things. We'll decipher brain in objective way, as objective as possible. Okay. Um, and if you look at these two guys, both are 5'5", and can anybody guess why these um, shorter, not so tall batsmen usually are better? So I'm sort of stay with me, okay? Because I'm changing these questions. So I still see some people answering this Maruti question. Ignore that. Uh, Here is a new question. Why do you think most batsmen, I'm assuming everybody understands cricket, so they are usually not very tall. So you think strength, Swarna, okay? The picture angle perspective, responsibility of prop. Yeah. So okay. So if you are shorter, your hand-eye coordination will be much better, because your eye is looking at this ball, and then the eye is giving direction to the brain saying, hey, this ball is curved. And then the brain has to then give direction to your arm and the wrist or whatever to hit that perfect shot. So if you are shorter, it is faster, so less time to travel for these impulses, these, and therefore quick. uh, Shruti, it's not reflex, really. It's brain deciding. Reflex is something else. We'll cover reflex. Okay. Yeah. So there's less time to really travel, and therefore it's faster. Anyways, yeah, basketball is a separate game, Amog. There is this basket on top, and so that's a different game. Anyways, so let's move on.